Is the next video in my series of short talks about astronomical objects, and we're going to concentrate today on ice giants, the planets Uranus and Neptune, out there in the outer reaches of the solar system. So to begin with, ancient peoples knew of the planets that they could see with the naked eye: Mercury, Venus, Mars, Jupiter and Saturn. And then beyond Saturn, the outermost of these planets, they thought was the realm of the fixed stars. And of course, it took the revolution of Copernicus to put the sun in the center of that rather than the Earth, and Newton to explain that gravity was responsible for all of these individual planets orbiting around the sun, or in the case of the moons of the planets, orbiting around their parents. Now this is Sir William Herschel and a picture of his 40-foot telescope. His telescopes were named not by the diameter of the mirror but by the length of the tube, and this was a very large instrument mounted on a turntable. But he made a rather smaller telescope. Here it is. You can see this in the Whipple Museum in Cambridge, or at least a copy of it. And the story goes that in March of 1781 he was in his back garden in Bath, and he was observing, looking for double stars and comets, and he saw in the constellation of Taurus an object that appeared to be not a star. All stars look round, no matter what the magnification you use upon them. They still are a point of light. But this particular object looked like a diffuse fuzzy object and therefore couldn't be a star. So he initially thought it was a comet, and realized that as he increased the magnification up to the fantastic powers of that are quoted on the page here, 400, 900 times even, that the disk of this object got larger. So he realized that he definitely found something and reported it to the Royal Astronomical Society. And after a while they tracked the orbit and discovered that it was moving in an elliptical orbit around the sun that was fairly nearly circular, not the long, thin, nearly parabolic orbits that comets do, where they rush into the solar system and then disappear back out again, crossing the orbits of all the other planets. Eventually, therefore, they realized he had discovered a planet and was the first person to do so since the invention of the telescope. Nowadays, we call the planet Uranus, and there was a long debate about this. Herschel himself tried to name it Georgius Sidious, naming it after King George, because I think he wanted to be appointed royal astronomer. But the French didn't like that very much. They suggested calling it Herschel, but eventually Uranus, the father of Saturn, came to be the name, and that makes sense because it's the next planet out beyond Saturn. It's a little bit of a curious object, though, because we've discovered that it has a faint system of rings around it, and that it's tipped right over at 97 degrees, so more than a right angle of tilt compared to the plane in which it's orbiting around the sun. You can see the tilt of the four major outer planets there in the graphic at the bottom right. Jupiter almost straight up and down, Saturn tilted at about 25 degrees, and the outer planets there, the ice giants, Uranus 97, so tipped right over, and a fairly significant but sensible tilt for Neptune as well there. Now this means that the seasons on Uranus must be particularly crazy, because if you can imagine it orbiting around the sun, sometimes the direction of the spin axis is pointing almost straight at the sun. Other times it's pointing at right angles to it. So you can imagine that for half the year, one half of the planet would see the sun and the other will be in total darkness. And then at the other times of the year, you'll get more or less normal daylight, nighttime, as the planet spins around. There's a nice few little graphics of it here, again showing a few clouds on the surface of the pale bluey-green disk, and those rings that are just about imageable from a Hubble Space Telescope here. And indeed, a few of the moons of Uranus there that have been picked up. It has 5 that were easily detectable, and lots more of the tiny moonlet, rough potato shaped objects that are being discovered more and more of as time goes on. Now, when we look at the internals of Uranus, we find that there is a rocky metal core, very similar in structure perhaps to the what we have for the Earth or the inner planets, but then it's overlain by a vast amount of material in the form of water and ammonia and methane, and an outer envelope comprising hydrogen and methane and helium right out there at the top. And that's why we call these planets, Uranus and the next one, Neptune, ice giants, because the mantle is made of these ices, these frozen up water, frozen up ammonia and methane at fairly low temperatures. Has a very interesting collection of moons. This is Miranda. It's only 470 kilometers across, and that makes it just about large enough for its self-gravity to have pulled it into a round body. That's the most efficient way of packing material together under gravity, is to put it all into a sphere, into a ball shape. But for that to happen, the amount of gravity has to exceed the strength of whatever the object is made up of, in this case mostly ice, and so make the ice become plastic and flow to that minimum energy shape. But look down at the bottom there, you can see some amazing ice chevron and some really large cliffs down at the bottom of the object there. If you jumped off one of those cliffs, the weak gravity of this object would slowly pull you down. It'd take you 15 minutes to fall the 2 kilometers. This is the next moon, a little bit larger, 1200 kilometers, aerial. And Voyager 2 only approached this within 130,000 kilometers. So it's got a reasonable picture showing some cracks and grooves across the surface that look perhaps like some of the ices have been moving, and some evidence of activity. And evidence of activity on these icy moons often results in us turning out to find that there's a liquid ocean trapped underneath the ice crust. We're not sure for aerial. We didn't approach it closely enough to be able to make the measurements of any distortion of its magnetic field. Umbriel, very dark coloured moon. They've really had to wind the gain on the camera up to get this image at all. 1200 kilometers across, and again, we didn't pass it very closely, so rather difficult to see the structure. But there's this very curious bright ring up at the top there. Now, that isn't the pole of the moon, that's actually on the equator. It's just the orientation of the photograph. So again, maybe that is water ice or something leaking from an inner body of liquid. We just don't know at this point. Titania here, again, we didn't get a particularly close view of Titania, 500,000 kilometers, and 1600 kilometer diameter moon, so reasonable size. Mixture of grey craters and some evidence of an active surface. It's not got as many craters as it might have if it had been a purely dead object with no geology and movement of the surface. Here's Oberon, which is 1500 kilometers and is the largest of those 5 moons. And again, 660,000 kilometers away when we took this photograph from Voyager 2, so not particularly high resolution. Another mission to Uranus would be an excellent thing, and being able to go and inspect these moons much more closely. But there are some intriguing dark carbon-rich deposits in the center, those darker regions, that appear to have come up from the central parts of some large craters. So well worth investigating there if we ever get the chance. Now, the story of the discovery of these planets goes that there were problems predicting the future position of Uranus. Whenever they tried to use Newton's laws of gravity to plot its orbit and work out where it was going to move to next, the planet would behave for a very short time and then wander off. And this was most intriguing. And one day, the young man who was pictured in the top left there, John Couch Adams of Cambridge, was wandering in the bookshops of the streets of Cambridge and came across a book which talked about problems in modern astronomy and highlighted the affair with Uranus's orbit not being subject to calculation, and suggested that perhaps there was an outer planet as yet unknown pulling on it with its gravity that would be distorting the orbit, and maybe that was the explanation. Now, Adams was intrigued by this and set about trying to back calculate where such a planet might be and how big it had to be in order to do that. And it's a very complicated calculation when you have to take into account the gravitational effect not just of the Sun, but of Jupiter and Saturn and Uranus and this as yet unknown planet, and figure it all out, all with hand calculations. The same idea independently occurred to a gentleman in Paris called Urbain Le Verrier, who was a very famous astronomer and at the Institute in Paris. And he had the same idea and also set about doing a calculation at the same time. Now, Adams sent his calculations to Cambridge via the Royal Observatory at Greenwich. It took a long time before anybody took him seriously, and he had to press quite hard, but eventually a search was organised. Whereas Le Verrier sent his calculations over to the Berlin Observatory, and they took them seriously immediately, went out, and on the very first night made an observation. And they discovered that there was a small blue dot at that point. Now, here's the predictions that Adams and Le Verrier were making. So you can see at the top here we have Adams made a number of different calculations, each marked on here with these blue dots. Le Verrier's prediction was here, where the purple square is, and the discovery is at this point here, where the little triangle marks it. Now, that looks like quite a big scatter, but if you plot it on the entire orbit, where Neptune was actually found and where Adams and Le Verrier had assumed it might be, you can see just how close they were in making their predictions. They had slightly larger orbits for it, which both were based on using the apparent pattern in the orbits called the Titus-Bode law, which seems to give a numerical sequence to the distance for the other planets and even for Uranus that fitted into that pattern when it was discovered. So they assumed that the next logical place to put a planet would be the next place in that sequence, but Neptune wasn't quite that far out, so there were a couple of things wrong there. But as I said, the prediction was sent to the Berlin Observatory, a picture of it here, and the very first night they went out with a star map of the area and found it. Now, Adams' predictions had been searched for in Cambridge. This is the Northumberland telescope in Cambridge that was used for it. They started several months earlier than the Le Verrier's prediction had been put into action, but they were in the process of mapping the entire area rather than just having a look for one prediction. And indeed, the data that we have in the library there shows annotated maps with a small blue disk being spotted a couple of times, but nobody reported it. So sadly, Cambridge were scooped, and they could have been the discoverers of this new planet. Now, often when you discover something new, you can look back and look at a pre-covery reports of it. And doing this, we go back and discover that Sir John Herschel, the son of William, who had discovered Uranus, had in fact spotted Neptune on 14th of July 1830. He'd seen a small blue disk, but he hadn't reported it. So again, perhaps we shouldn't be too unhappy about being scooped. Of course, you've always got to look for Galileo in these things. And it turns out that this is a page from Galileo's notebook, and he spotted a small blue star, and he noted that it appeared to have changed position between the 28th of December and the 27th of January the next year there. And of course, that was absolutely perfectly the right coordinates where Neptune would have been. So I think we can really state that Galileo was the first person to truly discover it. So this is what it looks like with the Voyager 2 flyby, with those lovely clouds, this hugely deep blue colour, and we've got the great dark spot there and the scooter down towards the bottom. Here's a close-up of the great dark spot. It's like the great red spot on Jupiter. It's a giant storm, a hurricane, swirling winds. Neptune has some of the fastest winds. It's 1,100 kilometers per hour. Here's the great red spot and the cloud they call the scooter, and the lesser dark spot at the bottom there. And again, some ice clouds in the high atmosphere of Uranus. Not Uranus, Neptune. Here's the internal structure of Neptune, very similar to Uranus. And again, we have a rocky core, perhaps a little bit larger than the planet Earth. And then that mantle of water, ammonia and methane ices before an outer envelope of hydrogen, helium and other gases. And it's the mixture of gases that gives these two planets their slightly different bluey green and blue colours. Here are the high clouds imaged by Voyager 2 in the atmosphere of Neptune, just casting shadows in silhouette there. Quite a nice photograph. Those ice clouds high in the atmosphere. And here are some images of the changing weather patterns over a few years, taken from the Hubble Space Telescope all the way from Earth. So we can see how the white clouds and the spots and the bands are moving and changing all the time on this very active atmosphere. But the star of the show out here wasn't so much Neptune, I think, as Triton. Here's the surface of Triton with the wrinkled cantaloupe terrain at the top and one or two grooves running across it. And then the lower hemisphere there is covered in what looks like pink snow and ice, with lots of little dark spots on. And those dark spots, when you realise they're all actually little streaks pointing down the same direction around in the downwind direction through the thin nitrogen atmosphere of this fairly sizable, almost planet-sized moon in its own right. So what we think is happening is that heat from the sun is getting trapped under a clear glass-like layer of frozen nitrogen on the surface, and that acts as the same way as glass in a greenhouse, traps the heat until eventually the frozen nitrogen melts and then vaporizes and bursts up through and creates these enormous nitrogen ice geysers up into the atmosphere, carrying with it a lot of dirt and dirty material, which it then deposits downwind. So the picture on the left there is an artist's impression, with the shadow being the dark streak that we're seeing of these active geysers. But on the right, there are a couple of images taken looking back towards the sun at Triton, and you can see in the thin atmosphere a couple of plumes along the edge of the image of the planet there, which are the downwind plumes. Now, Triton is actually quite an interesting world because 2,700 kilometers across makes it slightly larger than the planet Pluto. Triton at the top there, Pluto at the bottom, taken by the New Horizons probe. But they're very similar from the point of view of density and chemistry and composition. They both have these active surfaces that look like they've not been around in terms of picking up lots of craters for more than about 50 million years. There are so few craters that have survived. All the others have been rubbed out by the activity on the surface. And it's quite possible that they've got warm liquid interiors. Again, these ice worlds all seem to have this structure of being warm and wet internally, which may be a consequence of radioactive heating or tidal effects of having a large neighbour. But nevertheless, it's quite a puzzle to work all of this out. So just a couple more shots here. There's a picture looking at Neptune and a few of its lesser moons that have been discovered, and also marking out the ring arcs and the rings that have been detected. So again, these outer ice giants, both Uranus and Neptune, have their own sets of thin rings, and there's a very small image of the moon Proteus there at the bottom. So there we have it. That was a whistle-stop tour once around the ice giants Uranus and Neptune. I hope you've enjoyed that, and see you for the next one.